Good morning, students. Today we will see about informed search. In previous class we have discussed about uninformed search, right? In today's class we'll discuss about informed search. But before that, we'll make an outlook of what is uninformed search. So in uninformed search, we don't have any knowledge about the information. Only with the problem definition we will forward for finding the solution in order to reach the goal. Right? So that is one of the disadvantage what we found in uninformed search. And in uninformed search we have discussed about the BFS and DFS strategies. Right? To overcome those problems, right, we will see about the informed search. Right? So but in informed search we will have a problem specific knowledge in that. From the problem definition we know which path to be chosen. The previous in uninformed search, they don't have knowledge about which paths to be chosen to reach the goal state. That is going to be overcome in the informed search. From the problem definition itself, it is going to find a solution, right? So where the solution is going to be found based on the heuristic search. We'll see what is that heuristic search. The informed search is also known as heuristic search. Why? Because it's going to find the solution, the most promising path using your heuristic value, right? So that is why the informed search is also known as the heuristic search. So let us consider this about the specific knowledge what we are talking about. This is where the search is there which don't have no bias. So what is no bias is we don't know about which preference to be taken for the path in order to reach the goal. Right? Suppose J is our goal. For example, J is our goal. In uninformed search, what we do is either if you go BFS or DFS, we will search either breadth-wise or we will search either depth-wise. Right? In order to find the goal, we have to explore all the nodes. Right? And one is forced to look where to find the answer. Right? So the complexity of finding the solution in order to reach the goal state is difficult, right, in your uninformed search, right? So now in problem specific knowledge, using informed search, the solution is going to be given with a hint, right? So already we discussed how to draw the state space, right? So consider this is an state space where we are going to have some of the heuristic function. We'll see what is that heuristic function. So in order to boost up the efficiency of searching, in order to reach the goal node, if you observe here, even though there is the n number of nodes, without exploring all the nodes, based on the hint which is given in the problem, we are going to search the goal node only on the left hand side of a tree where it traverses from A to B, B to G, G to L and L to O is your goal node, right? So this is going to be achieved through some of the heuristic value, right? So which means that instead of exploring all the nodes, all the paths, we are going to concentrate on the path which is going to lead us to the goal node, right? So in this way we can get more efficiency, right, in the searching strategy. So coming back to what is informed search, right? So it is going to have a knowledge, right? And it is going to tell us how far we are near to the goal state, right? And it also hints us a path which leads to the goal node, right? So it is going to explore only the less search space tree in order to make it more efficiency, and it is going to make a less complexity in order to achieve the goal node. Right? So this is going to be useful in the large space, right? The informed search is also called as heuristic search, as the goal node is going to be found based on the heuristic value. Now, we are talking about heuristic, right? What is heuristic? It is going to be a function which is going to find the most promising path, right? So it is going to take an agent. Agent, do you know what is agent? One who take actions by observing the environment, right? So it persists and it takes the decision. So the main goal what it is it is going to observe the path which leads to the goal node, right? So heuristic is going to estimate. If you observe here, it is going to estimate how close a state is to the goal state. right? And it is going to be represented with h of n. So as it is a heuristic value, we talk about h of n. N is nothing but the mode. And always the heuristic value is going to be a positive value, right? It is not going to be a negative. So with this heuristic method, we can't tell that is going to be best solution what we are going to receive, but still it guarantees that you may get a good solution with a reasonable heuristic value, right? So the admissibility of the heuristic function is given as. What is the admissibility? Is nothing but the value which is defined for the heuristic value should be always h of n is less than or equal to h star of n. So what is this h of n is the heuristic cost, and what is this h star of n is the estimated cost. So always the estimated cost should be less than or equal to h of n, right? So that is the concept where it is admissible, right? So to calculate the heuristic value, we have two different options for us. So the first is your Euclidean distance. The Euclidean distance will say about the straight line. So you have to just know how the heuristic value is calculated. When it been observed with the knowledge how we are transforming the values with the heuristic function, we'll see later, right? So Euclidean distance and Manhattan distance are there. So whenever there exists a straight line distance, then we have to approach the Euclidean distance, and when we want to calculate the value which lies with the vertical axis, then the distance should be calculated using a Manhattan distance. So the formula for calculating the Euclidean distance for the straight line is going to be the root of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? As it is dealing with the two axes of horizontal and vertical. When you talk about the straight line, it is going to be the absolute value of x2 minus x1 plus y2 minus y1. This is how the heuristic value is calculated. But normally this has been implemented for the searching strategies. We will calculate the f of n by the heuristic function and with the estimated value of it, right? So we'll see what are the algorithms which is being implemented with the heuristic value, right? Another example for the heuristic function is where we talk about the straight line, right? So whenever we want to find a path between the distances and it should be an optimal distances, then we can use this heuristic, right, search, right? So suppose here there is an example which is given when you want to evaluate the path between the Guwahati to Kolkata. So we will find the path of the nearby path which is going to give you a promising path with the less cost. So obviously the optimal solution is going to be found from the less cost, right? So this is going to be calculated with straight line as we are dealing with the paths, right? To find the path between some destination, source and destination, which gives us the least value. So here that can be implemented by finding the Euclidean distance between your Kolkata and Guwahati will give you the heuristic value, right? So which will be the less value, right? So this is one where heuristic value can be implemented in order to find the cost of a path cost, right? And also we can use this in a gaming, right? So which is the 8 puzzle game. So you know about the 8 puzzle game which we already discussed in the state space tree, and we know how to draw this, right? So now how the heuristic function is going to be calculated in this is, if you observe, so consider this is your initial state and consider this is your goal state, right? So now they will calculate what is your h of n. H of n is nothing but a heuristic value, right? So how the heuristic value is calculated is the number of tiles which is out of place will be considered, right? So if you take 2, 2 is being misplaced, right? If you take 8, 8 is being misplaced, 3 is at the same position, right? And if you take 1, 1 is misplaced. If you take 6, 6 is misplaced, 4 is placed in that, right? So far 4 has been misplaced, right? And then if you take here 7, if you take 7 is misplaced, right? And and 5 is at the same position. So if you take this, what is the heuristic value of this is going to be calculated as h of n is equal to 5. Why it is 5 is the initial state is compared to the goal state, which is the tiles is been out of a place is going to be calculated, right? So from this heuristic value, which is going to give us the less heuristic value, we will choose the path. How to attain the goal? We already seen how to attain the goal, right? You can move the tile either upside or right side, left side or downside, right? So we will get a tile moving of 4 options. So where that, in which option we will get the less heuristic value, and that is going to be the path which leads to the goal state, right? So that is where we choose the path. So it helps us to choose the path and we can make that as your current state. So from the current state it is easy to find the solution, right? Right. So as we will deal with the algorithms of your informed search, under that we will see what is your best first search, and then we will discuss about what is A star algorithm, and then we will discuss about hill climbing, right? So under the informed search we will describe these 3 algorithms. So how we discussed in uninformed search, we have discussed about the breadth first search, depth first search and iterative deepening search. Still there are more algorithms, but as per your syllabus we will be covered only these 3 algorithms in the informed search. One is best first search, one is A star algorithm, and another one is your hill climb, right? So what the best first search is going to do is it uses the heuristic function, and it is a generalization of breadth first search. We know what is breadth first search, right? So where the search is going to be in the breadth-wise manner, right? And what is the fringe or the frontier, what we used in the BFS and DFS, the same frontier is going to be used in this, and the frontier is going to be priority queue. You know about what is meant by priority queue, which means that which has the highest priority should be placed first at the queue, right? And we know the queue will follow first out principle, right? So you have to make sure that the priority will be placed first in the queue, right? So that will be the node which will explore further, right? And we have to calculate the cost function for each node, right? So that helps us to move where it has to go for the next, right? And this best first search is going to be implemented with 2 lists of nodes. One is open list and one is closed list. So what is open list is where the node is going to be placed when it is visited, it is going to be placed in the open list, and when you have started exploring the nodes, then the nodes which leads to the goal state, the node will be moved to the closed state whenever it is being explored, right? From the priority queue, right? So that is your best first search. So here there is a simple algorithm for your breadth first search with the help of your priority queue, right? So here as I told you, let fringe be your priority queue, right, containing the initial state, right? So we have a loop over here, right? So where until the goal state is found from the starting node, it has to loop, right? So we set a loop for it. So first criteria is if fringe is empty, then return failure, which means that no nodes being in the fringe, right? So it's going to return a failure. If not, if any nodes is being in the fringe, then we have to remove the first and place it in the node, right? So the node will be removed from the fringe and place it in the closed state. If node is a goal state, you have to check. If node is a goal state, then return the path from initial state to the goal state node. You have to return it, right? If the node which is being taken from the fringe is not the goal node, else you have to generate all the successors of the node and put the newly generated nodes into the fringe according to their value f. So what is this f is, as I said, it is a heuristic value which will be defined for every node, and since this is a priority queue, it is must to see that the value which is going to be lesser going to hold the priority first, right? So we have two conditions which you need to check. If fringe is empty, it is going to return a failure. If not, in a fringe there is going to be some node, so you have to remove it, right, and check whether the node is a goal node. If that is a goal node, then return the path from the starting node to the goal node. That will be the solution. If that is not the goal node, else you have to generate all the successors of the node and put the newly generated node into the fringe according to their F values, right? Why F values, again I am telling is, it talks about the priority. So the heuristic value which is less will have the highest priority, right? So this is simple algorithm where it states. So the best first search is also going to be a greedy best first search, right? So we know about what is greedy, right? So greedy makes us to choose the promising path, right? So this try to expand the node that is closest to the goal node, so that it helps us to reach the goal node efficiently, right? So what is the heuristic value? How we are going to evaluate this? F of n is equal to h of n. So h of n is going to be your heuristic value of the node, right? So to implement this, we will, as I told you, we will use two lists of it, right? So one is to store the node that have been generated but not have been visited, and the closed node is the node that have been already visited. So the explored node will be kept in the open list, and after visiting, the node will be removed from the open list and will be kept in the closed list, right? So this is a simple algorithm for the best first search, right? So the same algorithm what we discussed earlier, it is simple with help of fringe, right? So here we talk about what is your open and close. So how the node has been kept in the open list, how it is explored, and why we move to the closed list, right? So this algorithm is going to depict that. So we have to start with the open holding the initial state. Right? So the initial state of the node is going to be set in the open list. Now until a goal is found, there are no nodes left or open. We have to do this following step. It is like doing this operations, right, until the goal node is found. So what is the first step you have to do? Pick the best node on the open. So if no nodes, you have to pick first the starting node, right? And what talks about the best node is, I said about the priority queue which has the least heuristic value, right? Then after choosing that, you have to generate its successor, right? So successor is nothing but its neighboring node. So for each successor node, you have to do what you have to do. If it has not been generated before, which is not in the open list, evaluate it, add it to the open, and record its parent. Why we need parent is in order to find the path which exists from the starting node to the goal state, right? So every node has been kept in the memory in order to trace its child node until it reaches to the goal node, right? So if it is not been generated before, you have to generate it and record its parent. If it is has been generated before, change the parent if this new path is better, and in that case update the cost of getting to any successor nodes. Suppose if you find a node which is a better path, you need to choose it. So how we are going to choose it? That is going to be with a lesser value, right? So the lesser value will help us to find the better path. Now this is going to be repeated. If a goal is found, right, until the goal is found, it is going to be repeated, or no more nodes left in the open list. Right? So because we have to check in the open list and explore the nodes. So if these two are there, then you have to quit it, and else you have to return back to the step 2 until the goal node is found. Right? So this algorithm tells about how the open list and closed list is going to go. Right? So we'll see with an example, then you can understand better about this open and closed list. Right? So let us take an example for the best first search. So we'll take a two list, as I told you. One is called as the open list, another one is called as the closed list, and we said that it is going to use a priority queue, right, which is nothing but your fringe or the frontier, both are same, right. So what is given in this example is, if you observed a node, there are the nodes from the starting state, which is defined as the S, and it has been given with some value which is nothing but the path cost, right, and these are like your estimated cost, which is nothing but the h of n value is given, right. So what we discussed for breadth first search is f of n is going to be your h of n, which is heuristic value, right. So we will consider the heuristic value and we will take the node and we will place it in the open list, right, and the node which is been in the open list, if it has the lesser value, then we will explore the node and move the node from open list to the closed list as it is visited, right. So this is the process, we are going to repeat it until we find the goal node. Now this is your starting node. What is your goal node? Goal node is your G, right. So we have to start from here and we have to reach the goal node of G, right. So what is the starting node? Which is S is your starting node, right. So we start with the starting node S. Now that node is being visited, right, but that is the first node, which is a root node in that. So S is going to be visited. Now S, after visiting that will be kept in the closed list, right, because it is visited, right. So the unvisited node should be explored, right, so which is the neighboring node of the S. What are the neighboring nodes of the S? A and B are the neighboring node. So we have two nodes in which you have to make a path which leads to the promising path. That means which leads to the goal state, right. Either you can move through A or you can move through B, right. So you have given two paths in which you are going to decide the paths to be explored next, right. So how we are going to choose? Now what is the value of A? What is the value of A? Heuristic value. A's heuristic value h of n is going to be 12, right. So the heuristic value of A is going to be 12. What is the heuristic value of B? Heuristic value of B is going to be 4, right. 4. Now 12, 4 are there. I said this is your priority queue. You have to maintain the priority of the list which it has to be taken first, right. So what it does is, according to this, it will swap